Hey guys, welcome to TUC. This is Abhishek here. In this lecture, we are going to demonstrate dynamic memory allocation using malloc function. First, we understand what is the setback of the static memory allocation. We are going to allocate an array for 5 integral elements, and we will store the elements in array, and we are going to print it. So could be done as, first of all, let me do this thing, end of main, and in here the declaration of the array 5 is allocation of array, this, and then one variable which will be used for the iteration, int I. And now just a message, just print a message on the screen to enter the elements of the array. Please enter the elements, elements the array. Now the for loop for the iteration. This is the end of for loop, end of for, and I equals 0, I smaller than 5 plus plus I, scanf mod d ampersand a of I. So this is going to store the elements into the memory. Now I would like to print the elements. Printf, the elements are for, let's copy this, printf mod d a of I. This is our end of for. Let's execute this. G++ -o ab malloc demo ./ab 5 4 6 3 and 7. 5 4 6 3 7. So the elements are 5 4 6 3 7. So one array got created, and the 5 elements 5 4 6 3 7, right? 5 4 6 3 7 got stored in the array, and we have seen that it's working. Now let's take up an example. For instance, if I am storing the edges of the students in this array, and after some couple of times, if I need some more space, because we don't know that how many students are there, we have just assumed that 5 students are there, but I want some more space to store around 10 to 15 students. Okay, so for in that case, this is not going to be possible, because the way we have allocated this space, it is quite kind of concrete. It cannot be changed. So if I want, if we don't know actually, if we are not aware that how many students are there, so let's take up some big space. Say it is 50. For 50 students, I'm going to allocate this space. Fine. So this is an array for 50 students, and we have stored only 28 students' ages. Okay, this is the space which is going to be sufficient. This space is going to accommodate the age of 25 or 28 different students. So only this much amount of space is gonna be used, and rest of the space will be wasted. this is going to be wasted. So in the first case, lack of memory, we cannot grow or shrink the size of the array, and in the second case, the wastage of memory. So to rectify these problems, one scheme is there in our C language, which is going to be very much beneficial when we are quite unsure that how much space is needed, and that is called dynamic memory allocation. Dynamic memory allocation. Why dynamic memory allocation? Because the memory is gonna be allocated in the runtime, and in runtime itself we can change the size of the memory. Okay, and we are going to work on this dynamic memory allocation using malloc function. Malloc function. So before that, let's discuss about the different segments of the memory which is available for our C program. Lines are not parallel, so what should I do? No, lines are parallel. Okay, so the different segments of our C program, the memory available for our C program are, this is our text segment, this is our data segment, and then comes the heap, and this is stack, and this is the free memory. It's a free memory. Well, this heap and stack, these are growable. I mean, it grows in this direction, this heap, and this stack grows in this direction. Grows means this is the free memory. If they need some more space which is not sufficient according to this much given space, then it will grow downward and it will take some memory from this free memory, and it's going to accommodate the required size. And same is the case with heap. But the dynamic memory means the runtime memory is provided by the heap. This is a heap, is a kind of heap of space. Well, this stack memory is the implementation of stack data structure, but this is not the case with heap. Heap is not the implementation of heap data structure. Heap is just a name for the pool of memory. Okay, pool of memory which is going to be used for the dynamic memory allocation. Okay, so let's talk about the malloc function. I am going to comment this code, or else for clarity let's delete this part. Yeah, I have deleted. Alright then. The malloc function, actually there are there are 4 functions for dynamic memory, to work with dynamic memory. First one is malloc, another is calloc. First one is malloc, this is calloc, realloc, and this is the free function. We will talk about this malloc function, and we'll use free function also. Malloc function stands for memory allocation, and its prototype is void asterisk malloc in here size underscore t size. If we go for the man page, man malloc, we would get everything: the corresponding header file, the prototype of the malloc function. This size underscore t is a type defined data type which is available in std_def header file. Okay, and malloc function accepts the number of bytes which is supposed to be allocated. It actually accepts the unsigned integral type, this malloc function. Obviously it's quite obvious that it's gonna accept the size, the unsigned integral data type. So what is this void asterisk? Before NCC it was char asterisk, but now it has become void asterisk. This void asterisk makes malloc the more generic function. It is now generic. Generic means this malloc function, we are talking about malloc. This malloc function allocates a space for any kind of data type. Either it's char, it's int, it's double, you know, it's some structure kind of data type. So it can allocate any kind memory for any kind of data type. So it's returning void asterisk. Void asterisk means what? According to the data type, it returns the pointer of the memory. Which pointer? Well, if we take a closer look, then this is our heap data structure. Sorry, this is our heap memory, not data structure. Let me rephrase my statement. This is our heap memory, and we have some 20 bytes of memory. We need some 20 bytes of memory. So this is 20 bytes. This is a block of 20 bytes of memory. So malloc will allocate 20 bytes of memory in heap, and it returns the start address of that address of that memory segment, which should be stored in a pointer. So if it is returning the start address, then definitely it should be stored in a pointer, which is going to be used as a handle to access the memory of this allocated space. So I am going to allocate this space. I am going to request the operating system to allocate space for our C program dynamically, and I will allocate space for the integral data type. So the pointer should be int asterisk p. Okay, this is the pointer which we have allocated. It's always a good practice to initialize the pointer wherever we are declaring the pointer variable. It's always a good practice to initialize with null, or else immediately use it. So we can do like this: it has been initialized with null, or else we can also write like malloc. How much space do we need? Say we want to allocate space for 5 elements of which are of integer type. So we could write like 5 4s are 20, because we know that 5 elements should, one integral element takes 4 bytes of space, depending upon the operating system. Here I am using Linux, Fedora, and the compiler is GCC, so accordingly it takes 4 bytes of memory, one integral element. So but if we don't know, then it's better to write something like 5 into size of int, or else it's always a good practice to take in the number of elements. Printf, this is what I am doing. Please enter the number of elements, and int size equals, for better abbreviation, int size, this is our declaring the size variable, and scanf mod d ampersand sz. So we have taken in the size, and right here we have put the size sz into size of int. So if I take these, if I want to allocate this space for 7 elements, then 7 4s are 28. So for 28 bytes we need, and this malloc function will accept the argument which is 28. So it will allocate 28 bytes in the heap memory. 28 bytes is gonna be allocated in heap, and the start address will be returned. So that start address should be stored somewhere, and we have stored it in P over here. So let's execute this and let's see what is the problem. There should be some problem. What is this? Invalid conversion from void asterisk. Invalid conversion from void asterisk to int asterisk. What does it need? This is a kind of dimensional check in physics. Well, this is malloc, which is by default which returns void asterisk, but on the left side means the L value is of type int asterisk. So definitely we should typecast. Am I right? Yes, I'm right. I should typecast. The typecasting has been done, so there shouldn't be any problem. Definitely there's no problem, it's quite perfect. So now we have allocated this space. So further we need to store the elements in the array. For that, let's put a message like please enter the elements of array, and we need one iterating variable, that is I, which is commonly or globally or universally used. I smaller than sz, the size of the element, the array, and in here the scanf function, which will store the elements in the array. So mod d ampersand p of I, this will put the elements into the memory. So this is the end of for loop, and this memory allocated dynamically. Okay, elements have been entered. Now let's check the elements have been entered or not. Mod D. P of I, and over here just put a message like the elements are the elements of array, and it should be placed inside a for loop. Why do we do this? Let's take this and okay, fine. I think it's perfect. Let's execute it. /ab 5. It's not looking proper. Let's put some space over here. Now it will look proper. And now the elements 5, 4, 6, 8, 3, 7. 4, 6, 8, 3, 7. it's perfect, so it's working. And this size of about the size of operator, this is a compile time unary operator which accepts the type, type or size. It accepts some variable or some type kind of thing, and it will return the size of that variable or data type. And the size underscore t, it is a type defined data type, and which is defined in the std def header file. So it's always a good practice, if we allocate some space, it's always a good practice to check whether the space has been allocated or not. Okay, so for that, if malloc allocates the memory, then it returns the start address. But if malloc, in any case, if malloc is not able to return to allocate the space, then it returns null. So let's check if definitely this null must be assigned in p if the space didn't get allocated. So p double equal null. If it is so, then printf or f printf, and on the standard error device I'm going to put the message like error could not allocate the space. It's fine, I guess. Okay. And what is the case when the memory is not going to be allocated? We'll check it. 3 4 6 8. Fine, allocation has been done. And okay, let's do something like, what did I say? That this malloc function accepts unsigned integral type, means it should be signed, it shouldn't be negative or something. So let's change this and put -3. Okay, another problem. 3. Okay, could not allocate space, and then it's printing please enter the elements of array. Why? Because when this problem occurs, we should always exit our code. So let's use the exit function with status 1, which indicates the abnormal termination of the program. This status 1, it indicates the abnormal termination of the program, so it should work fine now. Okay, and don't worry about this this statement, because I didn't comment this before working on this part, so this quite natural that it will come. So this has been done, and let's do it. Let's now, and if we are going to execute the code list now, this kind of problem should not come now. So if I'm taking 3, see, this message came, and again our the command line input. So let's do as previous, size of int is our data type, and we have allocated the space dynamically, so we are supposed to free the space which has been allocated. For that, we have the free function man free. Wait, rather man malloc. This is our free function. This free function accepts PTR. What is that PTR? The PTR where we have allocated the start address of our memory segment, which is available in our heap. So but this P is located in stack. This is the, you know, this is the local variable which is available in main function, and malloc allocates the space in heap and returns the start address of that space, of that allocated space, and it is going to be stored in P. So this P is going to be used now as an argument for the free function, this P. And important stuff about this free function: this free function operates only on those pointers which are initialized. It doesn't work on the pointer which is uninitialized, or it has some null kind of values. So it's always a good practice to check if P double equal null, then, or else if it's not equal to null, then free P. That's all. Done. So when do we use this free function? We use this free function when the memory is no longer needed. So this part is done. We have allocated this. We have checked the null value in the allocated in the start address of the memory segment. If it is so, then it's going to print and it will exit the storing the elements into the space and then printing the elements, and after that I have deallocated the space. Okay, so it should work fine now. /ab 4 9 5 4 3 9 5 4 3. It's working pretty fine. Okay, so we can work with this malloc function in a programmer defined function also. So we can call a function that is called void underscore get space, and in here return malloc we should pass the size, and in here malloc sz into size of, and is going to return. And over here we can call malloc, instead of malloc, get underscore get space, and we need to pass the argument sz. And since it's returning void asterisk, so the return type should be void asterisk get space, and return of this malloc function, and the prototype should be placed right after the preprocessor directive. So this part is done. stdlib, because the malloc function and the free function both are present in this header file. So this part is done, I guess. Seven. It's perfect. Well, I hope you enjoyed, guys. Thank you very much. Thanks, gentlemen. God bless.